Bond order is one of the important bond parameter. See here, bond order. Bond order depends on electronic configuration. It depends on pi bonds and sigma bonds. It depends on the structure. It depends on the resonating structures. I mean canonical structures. Different aspects affects bond order. That's why bond order is one of the most important bond parameter. Bond order is proportional to stability and it is reciprocal to bond length. Based on all these things, we are going to calculate different numericals, and don't miss that one. Please check all the 6 calculations now we are going to calculate. Yeah, let us start with first question, which is on bond order. The bond order is maximum among the following. Option A, N2, option B, He2, option C, H2, option D, O2. See here they are given 4 different options. Option A is N2, option B He2, option C H2 and option D O2. They are asking which of the following has maximum bond order. And you know one more important thing. To know the bond order, first we have to know the configuration. Means filling of the orbitals in different bonding and anti-bonding orbitals. And see here one important instruction is there, that is less than or equal to 14 have one configuration and more than 14 have another configuration. First we have to know that one. First I will write. See here, less than or equal to 14 electrons. For this one, first electron enters into sigma 1s, and then sigma star 1s, and then sigma 2s, and then sigma star 2s, and then pi 2px, that is equal to pi 2py, and then sigma 2pz, and then pi star 2px, that is equal to pi star 2py, and then sigma star 2pz, okay, keep aside. And then greater than 14 electrons. For the molecules with greater than 14 electrons, then it is equal to a small variation. Here sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, and then here instead of pi 2px, first it will come sigma 2pz. Sigma 2pz will come first, and then pi 2px, which is equal to pi 2py, and then as it is. And see here, and then here we will get pi star 2px, that is equal to pi star 2py, and then sigma star 2pz. Here you have to notice the difference when the electrons are less than or equal to 14 electrons and greater than 14 electrons. Difference will be here. Okay. Now we will check. In case of nitrogen, how many electrons are there? Each nitrogen has 7 electrons. N2 in the sense 2 nitrogens, 14 electrons. 14 electrons in the sense we have to find out this one. And see here, after finding number of electrons in bonding and anti-bonding electrons, how we will find out bond order? Bond order is equal to number of bonding electrons minus anti-bonding electrons by 2. If you use that formula, we can find out bond order. Okay, here I will write bond order BO is equal to number of bonding electrons minus number of anti-bonding electrons by 2. Number of bonding electrons in case of nitrogen. How many electrons are there? Total 14 electrons are there. Okay, and see here 2 2 2 2 2 2 1 2 3 4 5 6 7 7 twos are 14 electrons. Okay, here how many bonding electrons are there? Let us check that one. 1 2 3 4 5 5 twos are 10. 5 twos are 10. Therefore 10 minus number of antibonding electrons means with a star 1 2 2 twos are 4. 2 twos are 4 by 2, that is equal to 10 minus 4 6 by 2, that is equal to 3. Therefore the bond order of nitrogen is 3. Okay, I will write here bond order of nitrogen is equal to 3. I hope it is clear to everyone. Next we will go to helium. In case of helium, how many electrons are there? Each helium has 2 electrons. Helium 2 in the sense 4 electrons. 4 electrons are less than 14 electrons. That's why we have to use this one. 2 2. That means 4 electrons are there. 2 are in bonding orbitals and 2 are in antibonding orbitals. Now number of bonding electrons in helium 2, antibonding electrons 2, 2 minus 2 by 2, that is equal to 0 by 2, that is equal to 0. Okay, and see here the bond order in case of He2 is 0. Clear? Now we will move to third one, H2. Each hydrogen has 1 electron. H2 means 2 electrons. See here the 2 electrons are filled in case of sigma 1s2. Let us check bond order. See here number of bonding electrons 2 minus antibonding electrons 0 by 2, that is equal to 2 by 2, that is equal to 1. Therefore bond order of hydrogen is 1. Bond order in case of hydrogen is 1. Next one is oxygen. Each oxygen has 8 electrons. Each oxygen has 8 electrons in the sense O2 has 16 electrons. 16 in the sense it is greater than 14 electrons. We have to follow this one, not this one. Okay, clear? Now see here 16 electrons. 2, 2, 2, 2, 1, 2, 3, 4. 4 twos are 8. Still 8 more are there. 2, 2, 2 and here 2. 1, 2, 3, 4, 5, 6, 7, 8 twos are 16. Now the 16 electrons are arranged like this. Now we have to check number of bonding electrons and number of antibonding electrons. 1, 2, 3, 4, 5. 5 twos are 10 bonding electrons. Minus antibonding electrons with star mark. Okay, 1, 2, 3. 3 twos are 6. Number of bonding electrons 10. Number of antibonding electrons 6. 10 minus 6 by 2, that is equal to 4 by 2, that is equal to 2. 4 by 2 is equal to 2. Now the bond order in case of oxygen is 2. Clear to everyone? Now what is the question here? They are asking maximum bond order. Which of the following has maximum bond order? 3, 0, 1, 2. Now you tell me which is the correct answer. The correct answer is nothing but option A, nitrogen. Next question is based on fractional bond order. And see here few molecules they have fractional bond order. Now we will check one question on that one. Fractional bond order is in option A, O2, option B, O2 plus, option C, O2 minus 2, option D, N2. Here they are asking which one has fractional bond order. Okay, first we will do one thing. First we will find out the bond order present in all these 4 options. Later we will check which one has fractional bond order. Okay, and see here ABC options belongs to oxygen. Then we have to go with this configuration, I mean the order of filling electrons in bonding and anti-bonding orbitals, and in case of N2 we have to use this one. And see here oxygen. See here oxygen, how many electrons are there? How many electrons are there in case of oxygen? There are 16 electrons. Okay, and 2, 2, 2, 2, and see here. Now just now before calculation we calculated, that is 10 minus 6 by 2 is equal to 4. 4 by 2 is equal to 2. In case of oxygen it is 2. Bond order is equal to 2. In case of O2 plus, see here how many electrons are there? Plus in the sense it has to lose 1 electron. Now then what will happen? O2 in the sense 16 electrons, and plus in the sense it has to lose 1 electron, means 15 electrons. For more than 14 electrons, what we have to do? We have to take 15 electrons here. 15 electrons in a sense, just I am changing only this one, because just now we calculated for oxygen 16 electrons. Now we are going with 15 electrons. The change only here. And see here. Now, number of bonding electrons 1, 2, 3, 4, 5. 5 2s are 10. It's fine. Number of anti-bonding electrons 2, 2, 4, and here 1. 5 is there. 10 minus 5, that is equal to 5 by 2 is equal to, what is that? 2.5. The bond order is 2.5. I think this is our answer, because they are asking what is that they are asking which one has fractional bond order. Already we got that one, fractional bond order 2.5 for O2 plus. Then we will check for remaining things also. O2 minus 2 in the sense O2 has 16 electrons, and O2 minus 2 in the sense we have to add 2 electrons, that is 18 electrons. 16 plus 2, 18. Now see here, 1, 2, 3, 4, 5. 5 2s are 10 bonding electrons, and number of anti-bonding electrons will change here. 1, 2, 3, 4. 4 2s are 8. 4 2s are 8. Now here 10 minus 8 is equal to 2. 2 by 2 is equal to 1. Then bond order is equal to 1. Bond order for O2 minus 2 is 1. And in case of nitrogen has 14 electrons. Nitrogen has 14 electrons. Less than or equal to 14 electrons, we have to follow this configuration. Nitrogen, and see here 14 electrons, 2, 2, 2, 2, 1, 2, 3, 4, 5, 6, 7. 7 2s are 14 electrons. Check the number of bonding electrons. 1, 2, 3, 4, 5. 5 2s are 10. Minus number of anti-bonding electrons 1, 2, 2 2s are 4. 10 minus 4 by 2, that is equal to 6 by 2, that is equal to 3. Therefore, bond order is 3. Now, what they are asking? They are asking which one has fractional bond order. Which one has fractional bond order? O2 plus has fractional bond order, that is equal to 2.5. Then what is the answer? Option B is right answer. Next one, which of the following is paramagnetic with bond order 0.5? Option A, O2. Option B, F2. Option C, N2. Option D, H2 plus. They are asking which one has a paramagnetic with bond order 0.5. And you have to learn one important point here. Paramagnetic in nature is shown by the molecules with unpaired electrons. Okay? And if they have only paired electrons, it will be diamagnetic in nature. If it has unpaired electrons, paramagnetic in nature. Now we have to find out which one has a paramagnetic and also with bond order 0.5. And see here, O2. We already calculated bond order for O2, that is equal to number of bonding electrons 10, anti-bonding electrons 6, and by using the formula, bond order is equal to number of bonding electrons minus anti-bonding electrons by 2. 10 minus 6 by 2 is equal to 4 by 2, that is equal to 2. We already calculated this one. That's why I am writing directly here, bond order for oxygen is equal to 2. Now we have to find out for F2. See here, fluorine has 9 electrons, F2 has 18 electrons. 18 electrons in the sense greater than 14 electrons. We have to go with this one. Okay. And see here, 2, 2, 2, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 twos are 18 electrons are filled. Okay. Now we have to check the number of bonding electrons, that is 1, 2, 3, 4, 5. 5 twos are 10. Now we have to check anti-bonding electrons. Out of 18 electrons, 10 bonding electrons in the sense 8 are anti-bonding electrons. Therefore, 10 minus 8 by 2, that is equal to 2 by 2, 1. Therefore, bond order in case of F2 molecule is 1. Clear to you? Next, nitrogen. Nitrogen also we already calculated in previous one, and nitrogen has 14 electrons. Less than or equal to 14 electrons, we have to follow this sequence. We already calculated that one. In that one, number of bonding electrons in case of nitrogen 10 and number of anti-bonding electrons 4, that is equal to 10 minus 4 is equal to 6. 6 by 2 is equal to 3. We already calculated, that's why I am writing the value directly. Therefore, bond order is equal to 3 in case of N2 molecule. Now, see here H2 place. They asked paramagnetic with bond order 0.5, 0.5 not at K, maybe. Option D is the right answer, we will check it. H2 plus. See here, hydrogen has 2 electrons. H2 molecule has 2 electrons. Plus in the sense it has to lose one electron. Finally, it has 1. Means 1 electron. 1 electron in the sense, see here, number of bonding electrons. Number of bonding electrons 1. Anti-bonding electrons 0 by 2, that is equal to 1 by 2. 1 by 2 in the sense 0.5. Bond order for H2 plus is 0.5. Whatever 0.5 bond order they are asking, we got it in case of H2 plus. And see here it has only 1 electron. That too, it comes under unpaired electron. Its behavior is paramagnetic in nature. Paramagnetic in nature. Even in case of oxygen, it has unpaired electrons. It is paramagnetic but not with 0.5 bond order. Now, our answer is option D, H2 plus with paramagnetic nature and also bond order 0.5. Now they are asking one interesting one. They are asking the order of bond length. See here, for the order of bond length, they are not giving anything related to bond length. They are given something related to bond order. And you have to know one important thing, bond order and bond length are inversely proportional. More the bond order, less will be the bond length. That is important relation among these things. Now we will find out bond order. Based on the bond order, we will check the bond length order. Okay, let us start. Here they are given different species. See here, O2 minus, O2, O2 plus. In all the things, 3 are present in different orders. I mean, different increasing and decreasing orders. Now we have to find out one by one. See here, in case of O2 minus, how many electrons are there? O2 in the sense 16 electrons. O2 minus in the sense 17 electrons. 17 electrons in the sense greater than 14 electrons. We will fill these things. 2, 2, 2, 2. And see here, after filling 1, 2, 3, 4, 5, 6, 7, 8 twos are 16. Here 17 electrons are there. I will write one here. Now, how many bonding electrons are there? 1, 2, 3, 4, 5. 5 twos are 10. 10 bonding electrons. Out of 17, 10 bonding in the sense remaining 7 are anti-bonding. 10 minus 7 by 2, that is equal to 3, 3 by 2, 3 by 2 is equal to 1.5. The bond order, here I will write bond order for O2 minus is equal to 1.5. Okay. Now O2. O2 we already calculated in two different things. What is the bond order? Bond order for O2 is equal to 2. Bond order of O2 is equal to 2. We already calculated. That's why instead of wasting time, I am writing directly. Okay. And next one, O2 plus. For O2 plus also we already calculated, but instead of neglecting all the things, I am going to explain that one. See here, O2 in the sense, how many electrons are there? 16. O2 plus in the sense, we have to reduce one number here. Then we will get 15. See here, now 1, 2, 3, 4, 5, 6, 7, 8. 8 twos are 16. Here we have to make 1. 1, 2, 3, 4, 5, 6, 7 twos are 14. 14 plus 1. 15. See here, number of bonding electrons 1, 2, 3, 4, 5. 5 twos are 10. Okay, 10. Now 15 electrons are there. Out of 15 electrons, 10 bonding in the sense remaining anti-bonding electrons. 10 minus 5 is equal to 5. 5 by 2, that is equal to 2.5. Bond order of O2 plus is equal to 2.5. See here, now which one has more bond order? O2 plus has more bond order. Next, oxygen, and then O2 minus. Then bond length order is just reverse to that one. Means this one has more bond length, and then oxygen, and then O2 plus. Now we have to check which one has such type of order. See here, O2 minus is greater than O2. Next, O2 plus. Option A is correct answer. See here, again I am telling, here I will write bond order is inversely proportional to bond length. If we know the order of bond order, we can find out order of bond length easily. Okay, hope you understood that one. First we have to find out bond order. Based on the bond order, we can write bond length order. The relation between these two things is bond order is reciprocal to bond length. Please. In fifth question, they are asking the correct order of O bond order. Okay, and see here they given three different molecules. H2O2 means hydrogen peroxide, O3 means ozone, O2 is oxygen molecule. They are asking the correct order of O bond order. We will find out. Hydrogen peroxide, H2O2. H2O2 in the sense, how many electrons are there? O2 has 16 electrons, H2O2 16 plus 2, that is 18 electrons. 18 electrons in the sense, we have to use this one. One, two, three, 4, 5, 6, 7, 8, 9 twos are 18 electrons. Out of these 18 electrons, how many number of bonding electrons? 1, 2, 3, 4, 5. 5 are bonding electrons. 5 twos are 10. Okay, 5 twos are 10 bonding electrons are there, and remaining 8 electrons are non-bonding electrons. 8 minus 2 is equal to, what is that? 2 by 2, that is equal to 1. Now, in case of oxygen, we already calculated. In case of oxygen, here I am writing bond order of H2O2 is equal to 1, and bond order of O2 we already calculated, that is equal to 2. In case of oxygen, it is interesting one. See here, ozone has 3 oxygen atoms. See here, it has double bond with one oxygen and single bond with one oxygen. Here it has one coordinate covalent bond. And see here, it has a resonating structure. Now see here, total 2 resonating structures are there. In case of ozone molecule, we have to find out the bond order by considering the resonating structures. Now, the bond order of ozone molecule O3 is equal to number of atoms in a molecule. How many atoms are there? 1, 2, 3. 3 atoms are there. How many resonating structures? There are 2 resonating structures. Number of atoms in a molecule by number of resonating structures gives bond order. Okay, 3 by 2 is equal to 1.5. Therefore, bond order of O3 is equal to 1.5. Means which one has more bond order? Oxygen has more bond order, and then ozone, and then hydrogen peroxide. Let us check. O2, O3, H2O2. Option B is the right answer. Okay, please check these things. And here important thing is, in case of molecules having resonating structures, we have to use the formula bond order is equal to number of atoms in a molecule by the number of possible resonating structures. And in case of remaining things, by using this electronic configuration, we can find out. Okay, please note down this one, important one. In 6th question, one interesting thing is there. That is, they are asking the bond order of CO bond in carbonate ion. What is carbonate ion? CO3 minus 2 is carbonate ion. Okay, and we will check that one. Under numerical sections, they will ask without options. See here, they are asking bond order of CO bond in carbonate ion, CO3 minus 2. See here, what is the structure of CO3 minus 2? Carbonate ion is, see here, it has a double bond with one oxygen and single bond with another one and single bond with another one. And see here, CO3 minus 2. See here one sigma bond is there, here one sigma bond. Out of these two, one sigma bond and one pi bond. And in case of this type of molecules, how to find bond order? See here, bond order is equal to 1 plus number of pi bonds divided by number of sigma bonds. See here, 1 plus how many pi bonds are there? 1 by number of sigma bonds 1, 2, 3. 1, 2, 3. That is equal to 1 plus 1 by 3. 1 plus 1 by 3 is equal to 4 by 3. That is equal to 1.33. 1.33 is the bond order of CO bond in carbonate ion. Okay. Once again, please check that one. In case of ionic structures, if they are asking particular bond order, you have to calculate based on the structure. First you have to write the structure, and then you have to find out number of pi bonds and sigma bonds, and you have to use the formula bond order is equal to 1 plus number of pi bonds by number of sigma bonds. Then here we calculated for carbonate ion. CO bond order for carbonate ion, that is equal to 1.33. Please note down. Under numerical section, they will ask these things without options. Okay, please note down.